Okay. Good morning, everybody, and welcome to our pre-calculus 40S class. Um, so I hope you had a good weekend and you're ready this week to learn and continue on learning as we try to finish up this whole Unit 5 booklet. So last week, just to kind of recap what we talked about, we we looked at exponents and solving exponential equations. So just to kind of refresh our memory what we talked about there. So we talked about this one in here where we can actually create an equation and solve the equation. The great thing about this is that we were able to write the equation using the same base. Because the base are the same, then that means the exponents have to be the same for the two sides of the equation to be equal to each other. So um, today, it's going to be a little bit different. This is where we're actually going to introduce the concept of logarithm. So something that we have not seen before prior. If you've never taken the pre-calculus 40 yet, you probably haven't seen this logarithm before. Um, so if we try to solve the following exponential equations, we realize that we cannot convert these into the same basis. So when you look at the 2 to what exponent will give us 10? And to kind of just take a look at what we've done last week, okay, I wrote down all of the base 2 here. 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, and then 2 to the 4th is 16. As you can see, 10 would fall between 8 and 16. 8 and 16. So 10 would be, I'll just write it down in here. So we know, let's rearrange some stuff in here. We know that 2 to the 3, exponent 3 is 8, and 2 to the 4 is going to give us 16. Okay, so, well, 10 is somewhere over here in between 8 and 16. So that means the exponent must be close to 3. And it has to be 3 and 4. Okay, so if it's 2 cubed, that's going to give us an 8. If it's 2 to the 4th, that's going to give us 16, too much. So we're going to look for somewhere in the middle. This is where we're going to solve to 2 decimal places the following exponential equations using trial and error. Right now, what we're going to do is we're going to do the trial and error, okay? So let's see, my calculator. Okay, so we can say, what about 2 to the exponent? Okay, so you're going to look for the exponent button, y to the x or x to the y button, 2 to, let's say, 3.5. 3.5. Okay, 2 to the 3.5, that's too much. That's 11.3. So now we're going to go 2 to the exponent 4. No, sorry, that's not 4. 2 to the exponent 3.4. Because earlier we did 3.5. That's too much. Oh, that's a loss. Also too much, right? Okay, little too much. What about 2 to the exponent 3.3, 9.84. So now it's going to be between 2 to the 3 point. Write that down. So earlier we did it 2 to the 3 is 8. And then we did 2 to the 3.5. That's going to give us 11 point something. I need to write it down. 2 to the 3.5. That's going to be 11.32 or 31. That's too much. What about 2 to the 3.4? That's what we tried. So 2 to the exponent 3.4 is going to be 10.55, 10.56. If you want to do 2 decimal places, it's still too much. So you're going to go 2.3, 2 to the 3.3. Let's see. 2 to the 3.3. It's going to be 9.85. 9.85. So between 2 to the exponent 3.4 and 2 to the exponent 3.3, it's going to be somewhere close between those two. We're going to try to get as close to 10 as possible. So it's going to be 2, I don't need the point there, to the 3.35, 2 to the exponent 3.35. Oh, okay, very, very close, right? About 10.19. Let's go here. 10.196 to 10.20. Let's see here. 2 to the 3 point, that's 3.5. So we're going to go 3.2. 2 to the exponent 3.32. Oh, it's going to be super close, right? 9.99. 9.99. So this one here is, as you can see, it's not an efficient way of figuring out the exponent, but this is approximately what's super, super close. So this is a trial and error. This is not the best way, but right now this is how we're gonna start learning how to do this one for now. So in this case, x is equals to 3.32 because 2 to the 3.32 is equals to approximately 9.99. So approximately super close to 10. Okay. Now let's try this one here. 25 is equals to 4 to the x. Now 4 to the x, let's just do that one for a second. What do we know about 4 to the x? We know 4 to the 1 is equals to 4. 4 squared is going to give us 16. And then 4 cubed is going to give us 64. Okay, so as you can see, there's like a big jump from here to here. So what we're going to do is we're going to try to figure out, it's going to be 2 point something to get close to 25. So let's just do trial and error in here. So using trial and error. Using trial and error, we're going to say, well, if we know is 4 squared is 16, okay? And what if we go 4 to the 2.5? 4 to the 2.5. Let's see what that gives us. 4 to the exponent 2.5. Oh, that's 32. Okay, so it's too much. So let's go 4 to the 2.4. Too much. This is too much. So let's go here. Let's go 4 to the 2.4, 27, 27.86. It's still a little too much. Okay, remember what we're trying to do is figure out the exponent that when we apply the exponent, we're going to get 25. So let's go 4 to the 2.3. That's probably the next thing that you're thinking about. So it's going to be 24.25. Okay, that's a little less. Okay, so what we're going to do, we're going to put a little bit more. So 4 to the 2.335. Okay, let's go 2 to the exponent 2.35. Okay, that's 4 to the exponent of 2.35. We got 25.99. That's a little too much. So let's go here, 4 to the 2.32. 4 to the exponent 2.32. And we got like 24.93. Okay, so that's super close to about 25. So we can say using trial and error, okay, so we started off with 4 squared, that's going to give us 16. And then we went 4 to the 2.5, that's going to give you 32. And then we went 4 to the 2.4, that's 27.86. And then 4 to the 2.3, that's 24.25. So it's going to be, and then we ended up with 4 2.35, it's going to be 25.99. That's too much. And then we go 4 to the exponent 2.32. That's pretty close, 24.93. So we'd say that it's approximately the x is equals to 2.32. Okay. Since 4 to the exponent 2.32 is approximately equal to 24.93, which is pretty close to 25. Okay, so like I said, this is not an efficient way of figuring out this exponential equation, but that's a start to understanding logarithm. So it is difficult, as we can already see. It took us like a whole almost 15 minutes to do that. It is difficult and not efficient to use trial and error to solve exponential equation. That is why we use logarithm to solve equations, and we can't convert where we cannot convert to the same basis. We learn how to convert from exponential to logarithm and vice versa. So first of all, you're probably thinking, well, what is logarithm? Okay, what is logarithm? Logarithm is the looking for the exponent. Okay, so the logarithm is logarithm is the exponent that must be applied to the base to obtain the given number. So the word logarithm is figuring out what exponent must be applied to the base. So answering that question here, what is the exponent that I need, that I have to apply to the base to get this given number? Okay, so that's basically what it is, figuring out what the exponent is. So example number 2, what we're going to do is, this is a practicing between writing the exponential form and changing it to a logarithm form. So when we look at this one, so this, I'm going to look at this one here. So the 3 is the base, and then this, the little 3 there, this is the exponent, and then this is the given number. The given number. This is the given number. So what we're going to do is write down the logarithm. So this is going to be, you've never seen this one before yet, log of 27 base 3 is 3. Okay, so log of 27 base 3, log with base 3 of 27 is equals to the 3. So this one is the base. This is the exponent. Okay. And then the 27 is the given number that we're trying to figure out what we should apply that to get 3. So what we could do, okay, here's another thing that I could write about is this. So when we can, so 3 cubed is equals to 27. I can write that as log base 3 of 27. Okay, so what exponent do I need to put 27 base 3 to get a 27? So that could be written as log of base 3. 27 is 3 cubed. So the base is 3, the base is 3, so the exponent is 3. Okay. I don't know if that helped you a little bit, but let's go into the next one. This one here is the base. This one, the 0 is the exponent, and then this is the given number. So it's going to be like this, written like this. Log base 4, okay, base 4 of 1 is equal to what exponent? 0. Okay, so this is the base, this is the given number, and then this is the exponent. Take a look at this one in here. Okay. So which one is the base? This is the base. This is the exponent. And then this is the given number. So when you write that as a logarithm, log base 5 of what number? Of 1 over 25 is equal to the exponent. The exponent is -2. So the equals here is the answer. So figuring out the exponent. So this is the okay. Let's try this one. 10 squared is equals to 100. So that becomes log what base? Base 10. So this is the base 10. What is the number? Number 100. What exponent is that? 2. So figuring out what exponent should I apply to the 10 that will give me 100? The answer is 2. Okay, let's try this one. Log of base 2 log of 1/16 base using base 2 is equals to -4. So they're saying that what exponent do I apply to the 2 to get 1/16? And the answer is -4. And then last but not the least, log of 1/9 base 3. Okay, so what exponent do I need to raise? Do I need for 3 to get a 1/9? The answer is -2. Okay, so that's just converting it from one way to the other. And this is an important skill. So there are some practice questions for you to do on the book to do this one. Okay, so make sure you give that one a try. Now, that's changing from exponential form to logarithm form. But now, what are we going to do? How can we do it the other way around? How can we do it the other way around? How can we express logarithm to exponential form? So changing it from logarithm form to exponential form. Okay, so what does that mean again? So this is the base. This is the exponent. And then this is the given number. So log of 125 base 5 is equals to 3. So that becomes 5 exponent 3 is equals to 125. Okay, so this is the base. This is the exponent. And then this is the given number. Okay. Now this one, this is kind of interesting because it didn't specifically give us the base. It just says log of 1,000. So you're probably thinking, well, they forgot to give us the base in here. In this case, this is a when there's nothing written there, it's understood it's base 10. It's understood it's base 10. And this is called, so when they say log, and then they don't state the base, okay, it's going to be using without stating the stating the base means base 10. Okay, using base 10. And that is called a common logarithm. Okay, so here the base is 10. So that means 10 to what exponent? Exponent 3 will get us what number? 1,000. Okay, so this is the base 10. That's the exponent. And then this is what it's going to equal to. And this one here, this is starting to create the uh, equation here. So base is x. X to what exponent? The exponent is negative 4/3 is equals to 16. Okay, so this is the base, this is the exponent, and then 16 is what it's equal to. This one. Okay, so this is the base is 7. What exponent? 0. And 7 to the 0, what is it equal to? That's 1. Okay, now these two is just they reversed the side of the equation. That's the same thing. This is still the base 2. Exponent is negative 2. And 2 to the negative 2, what is equal to? Equals to 1/4. Okay, that one's not bad. Here, the base is 2. Exponent is 3. And what is that equal to? Equals to 8. Okay, so that one, both examples 1 and 2 talks about changing changing from exponential form to logarithm form, and then going back to logarithm form to exponential form. So make sure you practice those. Now, here we go. The following examples give some more practice with logarithms. It says here, evaluate. Oh, okay. Now we're not just writing it, but we're evaluating it. Okay. What's log of 125 base 5? Okay. Log of 125 base 5. So that one is really what you're asking for is this. Remember, log means what is the exponent. Okay, I'm gonna write that down. So this means what exponent must be applied to base 5. Okay, that's this base 5 to equal 125. Okay, so that's basically what you're asking for. Log of 125 base 5 is what exponent do I need for 5 to get a 125? So how can we write that? So 5 to what exponent will give me 125? And that's something that we learned last lesson on Friday, is solving exponential equation. We can rewrite this as base 5 as well. So 5 to the x, and then this is 5 cubed. So therefore, x is equals to 3. X is equals to 3. So when you see that, that's equals to 3. Now this one here, log of 1. The base is missing. It's understood 10. So it means, what exponent do I need to apply to 10 to get a 1? Okay, what exponent do I need to apply to 10? So this is what it looks like. 10 to what exponent will give me 1? Well, that's going to give us exponent 0, because 10 to the 0 is 1. Now this one here is, this is like a composite function, right? So you're starting off from the inside and then going out. So look at this one here. Log of 64 base 4. Log of 64 base 4. That means 4 to what exponent will give me 64? 4. Okay, I'm going to write that here. Log of 64 base 4. That's the same thing, or thinking about what exponent do I need to raise 4 by to get a 64th. So that's 3. So this answer is 3. So that means log of 3 base 3. Okay, so I'm going to put that there. And that. And then what exponent do I raise 3 by to get a 3? And then the answer is 1. Answer is 1. Okay. So that one's pretty cool. Now let's get into example 4. We're now solving for x. Solving for x. Okay, so this ones are straightforward. A little bit, it's not so bad. Log of x base 6. So we're looking for this one here. Okay, we're looking for this number. So this really means that 6 is the base, exponent is 3. What is that equal to? It's x. And then, so 6 cubed is equals to x. So 6 cubed means 6 times 6 times 6, or 6 cubed. It's 216. So x is equals to 216. Okay. Now let's take a look at this one. Log of 9 base x. So the base is missing. Exponent is given. And then it's going to equal to 9. So that means x to the 1/2 is equals to 9. So x to the 1/2, which is equal to 9. Okay, so how can we solve for x in here? Well, all we can do is to get rid of the 1/2 in the exponent. Okay, get the 1/2 in the exponent, we could square it. So we can square both sides. So 1/2 times 2, that's going to give us 1. Let's go this way. X to the 1/2 times 2. We're using the power rule over here, multiplying the exponent. So that's x to the 1 equals to 81. So x to the 1 is equals to 81. So therefore x must be 81. And then just to double check that, if I put 81 in here and I put to the raise it to the 1/2. That's going to give us a 9. Okay. Um, let's take a look at letter C. They're giving us the base, they're giving us the exponent, and then we're looking for the x there. So this really means 1/4 to the exponent negative 1/3, okay, is equals to x. So how can we do that one? Well, we could simplify this one in here. We didn't really have enough room in here to show our work, so I'll go sideways this way. We can make this a positive exponent by going like this. It's going to be, if I change it to a positive exponent, it becomes 4 to the 1/3. Okay, so 4 to the 1/3. Okay, just to kind of refresh our memory again, to change from a negative exponent to a positive exponent, we take the reciprocal of the base. Okay, only the reciprocating the base. 4 to the 1/3 still equals to x. And then when you look at this, what's 4 to the 1/3? That's the same thing as the cube root of 4. So the 3 denominator, 3 in the exponent, is the index for the radical, and then the 1 would be what 4 is raised to. So that one, the x is the cube root of 4. Okay, last but not the least, the base is missing. We got the exponent and we got what it's equal to. So let's see here. The base is missing. X to the 5/2 is equals to 32. Okay. So how can we do this one in here? How can we get rid of the 5/2 in the exponent? Well, what we could do is we can multiply it by its reciprocal to cancel that. So we can say we can multiply it by 2/5. 5/2 times 2/5. So I'll just write that down in here. Let's show it to you. So when you have x to the 5/2, and if I multiply it by 2/5, the 5 and the 5 cancel, the 2 and the 2 cancels, we're left with x to the 1. So that's another strategy of solving for x. So if I multiply this, or if I raise the left side with 2/5, then I have to raise the right side also by 2/5. So this cancels that, and then that becomes x equals to 32 to the exponent 2/5. Okay, so what does that mean? This means x is equals to, okay, the radicand is 32. The index for radical is 5 squared. So the fifth root of 32, is 2. 2, 4, 8, 16, 32. So that's going to be 2. Okay. Fifth root of 32 is 2. And then 2 squared is equals to 4. So the answer is 4. So here, the base is 4. Okay. So this one here, it's something that we are a new skill that we're learning in here. The converting it from exponential to logarithm and logarithm to exponential. As you can see, we did that pretty much in every single example in here. We changed the logarithm to exponential equation. Same thing in here. We changed the logarithm equation to exponential equation to solve our equation. Now this is an assignment time, certainly a must thing to work on. Page 381. These are the required practice. So please give those questions a try. And if you have any questions, please send me an email. If there's a question that you want me to um, go over with you or the whole class, then I'll be happy to do that for you. Okay. So thank you very much for watching today. And I will have this lesson and all of the notes posted on the blog, like all of the scan notes posted on the blog real soon in a few minutes. So I'll leave that with you. Um, okay. I'm gonna wait maybe a couple of minutes in here just to see if there's anybody that wants to has a question. Um, of course, you can type it in on the live chat because I can't hear you. That's a way to communicate, or you can, of course, email me. Okay. So I guess I'll leave you with that. And again, thank you very much for watching, and I'll talk to you later. Okay. Bye for now.